Let's review the buoyant force. The relationship between an immersed object's weight, the buoyant force on it, and its apparent weight for both floating and submerged objects is given by the equation the apparent weight is equal to the actual weight minus the buoyant force. Archimedes' principle is that the buoyant force on an immersed object is equal to the weight of the fluid displaced. And here are a couple of equations that deal with the buoyant force. This top one is for floating objects, and these equations here work for both floating and for submerged objects. So you might want to keep this little equation toolbox handy as we go through this lesson and the next couple. So here's a problem. We've got a tree trunk with a specific gravity. Not surprisingly, it's less than 1 because typically wood floats, and anything with a specific gravity less than 1 is going to float in water. And there's the volume of the tree trunk. Let's find the log's apparent weight, the buoyant force on it, and the volume of water it displaces. Well, the log floats, so that means that the apparent weight of the object is 0 newtons, because the buoyant force and the weight of the log are numerically equal. The buoyant force then is simply equal to the weight of the log. Well, how would we find that? We'd take the mass of the log times 9.81, the acceleration due to gravity. Now, we weren't given the mass of the log, but we were given the volume of the log, and based on the specific gravity, we can calculate the density of the log. The density of the log is going to be 410 kilograms per cubic meter. There's the volume, 0.79, and there's the acceleration due to gravity. So the buoyant force is numerically equal to the weight of this log, and that is 3,200 newtons. How about the volume of water that is displaced? Well, certainly it's going to be less than 0.79 because the log is floating. And for floating objects, we can use the what I call floaty rovy equation, where all of the quantities except for the displaced volume are known. We know the volume of the fluid to be 1,000 kilograms per cubic meter. There's the, did I say that right? We know the density of the fluid to be 1,000 kilograms per cubic meter. We know the object, we know the volume of the object. So the volume displaced is 0.33 cubic meters. Final thoughts. The buoyant force is always equal to the weight of the fluid displaced. If the object is floating, as the Titanic was originally, the displaced fluid weight and the weight of the object are equal. If the object is submerged, the displaced fluid volume and the object volume are equal.